Cancer cells are immortal? But what does that mean? I'm going to explain 2 mechanisms in which cancer can be immortal. Right? This is called limitless replicative potential, and 2 ways in which they do this is evade senescence, or they escape senescence, as well as evade mitotic crisis. What is cellular senescence? So senescence is basically like the cell going to sleep or the cell in a coma. It's just kind of sitting there waiting to undergo apoptosis. And what is mitotic crisis? Mitotic crisis is when your telomeres get too short and you run the risk of DNA damage as you continue to replicate. Evasion of both of these are mediated by p53 protein defects. And if you remember, p53 is an integral part of helping diagnose DNA damage as well as helping repair that. If you have p53 defects, you can't cause senescence, you can't cause apoptosis, because you can't diagnose the damages or the defects in the DNA, or you can't see the low telomere levels, right? And there's other mechanisms in cancer where it actually allows it to upregulate telomerase expression, and we'll get into that in some other videos. Honorable mention, also under limitless replicative potential, you have self-renewal. This is when tumor cells arise from stem cells, and you can see this in acute promyelocytic leukemia as well as chronic myelocytic leukemia. And acute promyelocytic leukemia, or AML, is going to be due to translocation of the 15 and 17 chromosome, while chronic myelocytic leukemia, or CML, is going to be due to translocation 9 and 22 chromosomes. But anyway, I hope you like this short about limitless replicative potential. If you want to take a deeper dive with me, I have a longer form video where we take a deep look at acute promyelocytic leukemia, chronic myelocytic leukemia, and Burkitt's lymphoma. We're going to talk about how the translocation of these chromosomes and the fusion of the genes lead to the production of this disease as well as its progression. Alrighty, see you next time.